So now let's look at section 3.7 in the book. It's solving system of equations with Cramer's rule. So we're going to learn some key terms and ideas and then apply this Cramer's rule that we're going to be learning about. So one of the first terms you need to learn is called the determinant. So the determinant is the difference of the products of the two diagonals in a square matrix. That's called the second order determinant in a 2 by 2, right? So here we have a 2 by 2. 2 rows and 2 columns. And if I want to take the determinant of that, all that is you take the terms that are there, right? And you're going to put these bars automatically. It looks like absolute value, but if it's a matrix, it's called the determinant. What you're going to do is, like it says in the instructions, it's the product of the two diagonals. So this diagonal, A times D, you write it down, and then you subtract B times C. So it's kind of a crisscrossing A times D minus B times C. So you can do that kind of quick. So if you look at the example that they give us, so if this is my matrix, I placed it already to take the determinant of it. So I placed those lines on it that look like absolute value, and I just do the application. So I take 4 times 6, and I'm going to subtract the 5 times negative 3. So be very careful, because one is minus from the problem, the other one is a negative that's in front of the 3. So 4 times 6 is 24. 5 times negative 3 would be negative 15. However, a negative times a negative gives you a positive 15. And so now if you just add those two, because it turned positive, 24 plus 15 gives you a total of 39. So the determinant, if this was a matrix right here, the determinant of that matrix would be 39. So now, what if we have a 3 by 3 matrix, a third order determinant? So second order is kind of easy. You just crisscross, you're done. But now if you have 3 by 3, look at all the numbers that we've got in there. It's kind of the same. You're still dealing with the diagonals. However, you're missing some diagonals, right? Because if I go this way here, the negative 8, 6, I'm missing a number, right? So all you have to do is, here are the instructions. If you have a 3 by 3 matrix, what you do is just rewrite the first two columns. So I've got 4, negative 3, negative 4, negative 8, 2, 5, 3, 6, 9. All you do is rewrite these two over here on the right. So 4, negative 3, negative 4, there it is. Negative 8, 2, 5, negative 8, 2, 5, there it is. Once you rewrite them, check this out. Now you can do the diagonals going this way and then coming back this way. So I marked them off. So now just find the product. So let's start. So let's start with the first diagonal. You do 4 times 2 times 9. So there it is. That's 72. Then you take the next one, negative 8, 6, negative 4, negative 8 times 6 times negative 4, and then the third one in red. So 3 times negative 3 times 5, right there. Now you do the same coming back. So you take 3 times 2 times negative 4, there it is, 5 times 6 times 4, 5, 6, 4, and then 9 times negative 3 times negative 8, right there. And you get these two totals. Now, once you have the two totals, you take them and the three totals, right? Because it was one from each of the diagonals that were coming through. So then, what you're gonna do is you're gonna add them up, right? So total each group. So we the first time when I did this here is 72, 192. And the negative 45, that gives me 219, right? And the second group here gave me negative 24, 120, and 216. So I totaled those three, and I got 312. Now, you subtract the second one from the first total. So 219 minus 312 gives me a determinant of negative 93. So why are we doing determinants? Well, it's going to help us solve system of equations. Remember, because a matrix can help you solve a system. So let me just give you one of the examples you're going to see here is that you can calculate the area of a triangle also by using the determinants. So you take that triangle and you look at the vertices, and what you do with those is you set up a matrix like this. Now, if you'll notice, when to find the area of that triangle, it's going to be 1/2 of, and notice how you're going to set this up as a determinant. So AB is the first coordinate, so you place, let's say the coordinate was -1, 5, so -1, 5. Let's say then down here you get a different value, right, for the coordinates, you plug it in here, and for CD you do the same thing. It's a 3 by 3, so of course you're going to do your diagonals, find those determinants, and then you're going to multiply by 1/2, of course, and that's like we did up here. Follow the steps and you should be able to calculate it. So a determinant can help you also calculate the area of a triangle. So now we can use also Cramer's rule. So what is Cramer's rule? Well, Cramer's rule is a method that uses the coefficient matrix. Remember the word coefficient, it's the numbers in front of the letters. So it's going to be using the coefficient matrix and only has coefficients of whatever system of equations you're looking at. So let's let C be the coefficient matrix of the system. Here we have two systems, right? AX plus BY equals 2, like it would be a C, right? So it's a standard form. But all you do is you take these numbers, whatever is in front of the X, in front of the Y. Notice how they have to be in this order. They are both lined up, X, then the Y, then whatever number. So you would take the A, the B, place them inside a matrix, then the F and the G, place them inside like this. So that would be the first matrix that you would set up. And so now look at what happens. You take the, whatever the M number that's out here and the N, notice how to find the solution. So to find X, what you do is, let's take it a little bit slow. You're going to place whatever number is here and the N, so you place them here, and then you place the B and the G number from here in here. And then check out what you're going to do. You're going to take the determinant of your C, the coefficient matrix that you came up with. So you take the determinant by doing this minus that. That's going to be the number that's going to go down here. Then how do you find the Y coordinate? Well, the Y coordinate comes from taking the A and the F, you place them inside with the answers here, the numbers MN, MN, and then you can do your determinant that way, divided by the determinant of this coefficient matrix. Whoa, so I know it sounds like a lot, and it is, but you have the notes. So you really just need to slow down and see where did all these numbers come from. To find the X and the Y value, you get these numbers from whatever the equation was. So once again, M and N are whatever numbers are to the right of the equal sign of your system of equations. And the B and the G, you're saying, well, I'm solving for X, shouldn't I get the numbers here? No, it's the opposite. You get the ones from the Y, the B, the G, the B, the G. Then what you're going to do to solve this, you're going to take the determinant. Remember, you multiply M times G minus B times N. You get that total. You're going to divide it by the determinant of your coefficient matrix, which is the ABFG. ABFG. So you just A times G minus F times B. You divide those two. That, whatever number comes out, that's the X value. So that would be the answer of that particular matrix. And how do you find the Y? Same process. You take your, since we're looking for Y, then you take the A and the F coefficients. Those are your first column. And then you take the M and the N right there. So then you do AN minus FM. That'll give you the top number. Then you take the determinant of your coefficient matrix of this one. So it's AG minus FB. But if you already did it for X, then you should already have an answer. So it's the same number at the bottom for both cases. Just making sure that, of course, C is not equal to 0, because remember, we don't usually, we can't divide by 0. in the problems we do. So now, what if you have 3 equations? Whew, this is where it gets really, really hectic. But again, make sure you write these notes down and then practice with some problems like we're going to be looking at right now. So how do you do that? Well, here's equation 1, equation 2, equation 3. I want you to notice something. They're all lined up with the x first, y next, z next, and then of course some kind of equal to some constant number, right? So what do? First, you take the coefficient matrix, just like we did up here, right? All the coefficients. So A, B, C, whatever number's here, whatever number's here, whatever number's here, write it down. Then F, G, H, and then J, K, L, J, K, L. So now, how do we find x? Just like we did up here, to find x, what you do is you put not the x, because that's what you're looking for, but you put the other guys, right? So you're going to put the B and the C number, the G and the H number, and the K and the L. B, C, G, H, K, L. And what goes in the first column here? You put the, whatever the answers were from your actual 3 equations. So 1, 2, 3 numbers, the M, the N, and the P. And what do you do at the bottom? The bottom is going to be the determinant of this. Now remember, this is a 3 by 3. So in this case, you're going to have to go to this example because this is a 3 by 3, right? Remember, it's not just, diagonals, subtracting the diagonals. This time you have to draw the 2 columns again and then do your diagonals and do your work. So it is a little bit time consuming, but it requires a lot of practice. The only way you can get good at doing these is practice, practice, practice. Even myself, when I had to do these in high school and in college, I practice, practice, practice so that you can see where all these are coming from. So how do you get the y value? The y then comes from your A and C. So notice how now, see, because we're looking for the y. So now you take this one and then the M. So there's your A and your C. Look at that. Now your M and P, here it's in the first spot, here it's in the second spot, here it's in the third spot. See, there's always patterns in case you forget how to do these. That's what you would do. And let's look at how you find the Z. So can you already guess? If I'm looking for the Z, I'm not going to be using these letters. It's going to be probably A, B, F, G, J, K. And sure enough, A, B, F, G, J, K. Plus in the last column, I've got the M and P numbers, whatever numbers are there. Remember, here you don't put any of the letters. You're only putting the coefficients. Those are the numbers in front of the letters. And then you take the determinant, of course, of the C. You divide those, and that'll give you the x value, the y value, and the z. So remember earlier, you were solving system of equations by graphing them, building a table, putting them on a calculator, doing something to help you see where they overlapped, where there was an intersection. And so now we're actually using this particular rule called Cramer's rule to solve the matrices. So now if we look at your packet on section 3-7, solving system of equations using Cramer's rule, you're pretty much going to get the same notes that I gave you in my Cornell notes. So try to copy my notes first, and then, just kind of review them, do a summary, write any questions you might have to the left-hand side, and then come and look at the packet. So it basically explains the determinant. This is the one, the determinant I had just gone over in the notes. And so it basically shows you how to find the determinant, right? So practice those questions as well. Then you're going to practice on how to find the determinant for a 3-by-3. And so notice how they did the same thing. They rewrote the 2 columns here. And so you're going to be doing the same thing when you solve these problems. So then, of course, they continue showing you now using Cramer's rule. So in a bit, and remember I mentioned that to find an area of a triangle, you can do that as well. Use the determinant also to find that. So you can practice with those questions. But here, finally, is Cramer's rule. And so I put it in the notes. So it's the same information that's here. So just kind of go over it again. Here, they actually ask you to practice. So remember that you take, these are the, A, B, and the answer, M, N, and so on. So here they actually show you how to set it up. So if you're looking for the X, remember that's where you would not include the X numbers, but you include the Y's over here, which is like the 4 and the 2. And if you notice, that's kind of what they did. 4 and the negative 2, I'm sorry, right here. And then, of course, the answer, which is 28.8, so that's what they put here. So again, substitute those values, practice doing it just like you saw me do it earlier with the example in the notes. And so then you practice these. Now, the one that's going to take a little longer is Cramer's rule, but for 3 equations. So make sure to do a few of those just to make sure you got the correct information. Now, if we go over to the actual study guide, you'll see the same thing, repetition, just again reminding you. So go through each, look at the elements, what they do, copying over those columns, etc., how to find the area of a triangle, if you know the vertices and stuff like they did there. So then evaluating determinants is pretty simple. These are the ones that are diagonal. So let me do one of those for you just to continue with the notes. So I know to take a determinant, I multiply this times this. So 7 times 6 is 42, and then I'm supposed to subtract this times this. I know some of you are thinking when you see that, the cross multiplying kind of thing. Yes, but it's a different idea, but at least if that'll help you remember what to do. So then go ahead and do that. So 5 times negative 2 is negative 10. Remember, this negative comes from multiplying these. This minus comes from the actual instructions on how to do determinants. But the good thing about this is you're going to end up with a subtract the negative, so negative, negative, positive. So 42 plus 10 actually gives you a 52. So there's my determinant for that particular question number 1. This is going to require a little bit more work because remember you have to rewrite these first 2 columns. You're going to have to rewrite them here on the right hand side. And it continues, the study guide intervention, page 2 is about Cramer's rule. As I explained it, it really just takes you practicing it to be able to solve a system using Cramer's rule. So here are some examples that you're going to be working on. And so again, more practice on how to find determinants of different sizes and of course using Cramer's rule.